Hey guys, this is Coach Brian going over 1-2A, first part of lesson 1-2, which is about measuring angles. All right, measuring angles. So today we started class by just working on our practice, and then we talked a little bit about what angles are and how they're formed. Today our objective was to define and to measure angles. This again is a big part of our geometry foundation. You really need to understand how angles are formed and measured in order to really progress more comfortably in this class. So the essential understanding is when rays share a common endpoint, that forms an angle. So if I look here, see how I have this pink ray, okay, I have this pink ray here, and it is sharing an endpoint with this red ray, and so that's what we call a common endpoint. Since they have that common endpoint, between them is formed an angle, all right? Another place where angles are formed is at the intersection of lines, and so here I drew 3 lines. You could have more. I mean, really, you could have infinite, like we've been using that word a lot. But you can see all these lines cross, they all intersect at this one point, and around that point, there are now 1, 2, 3, 4, 5, 6 angles formed. So the more lines you add, pretty much every time you add a line, you get 2 more angles. So here are some types of angles. Some of these words you may have heard before, some of these you may not have heard before, but regardless, by the end of this unit, hopefully you know and are comfortable with all of them. But we've got different types and measures of angles on the top, and then we've got different pairs of angles on the bottom, which will be the next lesson will be pairs of angles. We talked about how to use a protractor. All right, and what a protractor measures, they measure angles, and the way they work is you have this point here, this like open, it's literally a hole in the protractor, and you put your pencil through there, and you would put it right on the point or the vertex of an angle. And then if you start on this side, okay, if you start on this side, let me switch colors. See how there's a 0 up top? If I start at that 0, I'm gonna count around the top of the protractor. But if I'm measuring something from over here, see how that 0 is on the bottom line, I would measure around the bottom line, okay? So I would use the numbers that are in line with the 0 on the side that I started on. We got into today's notes and we again said that an angle is formed by 2 rays that share a common endpoint. All right, 2 rays that share a common endpoint. And that common endpoint is what we call the vertex. This is a big vocab word for geometry here, vertex. Okay, it's the shared endpoint, or it's that point of intersection, if we're talking about lines, where angles are formed. And then last thing we talked about, we've got, you can see it right here to the side, we've got angle RST, and it's got this M out front. And when you see the M out front, that just means the measure of the angle. If you see that on a question, if it says find M angle ABC, it wants you to find the measure of the angle. So what we did is we took our protractor, we put that pivot point right here at S, we lined everything up here on the bottom, and so what it kind of looked like this. We had our protractor here and lined everything up and measured this angle. So when we measure it, or when we measured it in class, this number R was pointing to about 70 degrees. Okay, it was pointing to about 70 degrees. And so the measure of angle RST, we said this angle was 70 degrees. I guess I could write it right there where it goes, 70 degrees. Make that 7 a little better. There we go. All right, and then the next thing we talked about was naming angles. There's really 3 ways you can name angles. You can name them with their 3 letters. You can name them by the vertex, or you can name them with the angle number. So this picture right here has all three of those options. First, if we start with the three letters, we could name this angle RST, or we could go the other way and name it TSR. Now, on both of those, I hope you notice, S is in the middle. It's because if I start at T and go this way, S is in the middle. If I start at R and go this way, S is in the middle. The vertex always has to be in the center, okay? Vertex must be the middle letter. Another way we can name angles is actually using their vertex. So this one's vertex is S, so I can actually call this angle S. And then lastly, we can use the angle number. See how there's a number 1 in there? I could just call this angle 1. And if you're wondering, like, why would there be a number in there? If we go look back up here, we saw how there can be many, many angles at one intersection. And so the numbering system is sometimes just a way to keep everything quick and clean. All right, looking at angle sizes by measure, we can classify angles. If they are right angles, they're always going to be 90 degrees. All right, hopefully you've heard this term before. It's when an angle looks like this. It's a 90-degree angle. All right, 90 degrees. Straight up, straight down, straight over to right or left. Now, if you take a 90, okay, and you put it with another 90, like this, if you put it with another 90, you put them beside each other, 90 plus 90 gives you 180 degrees. It also gives you a straight line. So that is our straight angle at 180 degrees. Now, acute is when the angle is between 0 and 90, okay? That means it can be all the way up to 89.99, and it's still going to be acute. Now, as soon as it hits 90, it's then classified as a right. And as soon as it goes over 90, it's going to be classified as obtuse. So if it's between 90 and 180, that's going to be an obtuse angle. Also, just a reminder from last class, congruent means that two things have the same size, and not just that, they also are the same shape. Same size, same shape. Same size, same shape. All right, so using this protractor here, we were looking for the measures of the angles. And so I'm going to go kind of quickly through this, but what we did first is we found where each point was, starting at this 0. So we went up to A, and we marked it as 34. We went up to B, we marked it as 64, and then we kept going over to C. We kept going over to C, and we marked it as 130. Okay. Now, we could have also started over here and counted inside the lines. Okay, numbers would have been a little different, but our final answers should have been the same. So if you decide to go the other way, it's okay. Just make sure that if you pick a starting point, you measure everything from that point of reference, okay? So with angle AOB, that's the angle that starts at A, goes to O, and then terminates at B. So it's this wedge right here. Okay, that's what we're looking for, is this wedge. And so to find that, you need to find the difference between these two values. And so the difference is 64 minus 34, which leaves me 30 degrees. So we would say angle AOB is 30 degrees. 30 is less than 90, so we would say this angle is acute. And then you would just follow the same process. If you wanted to find BOC, that's the angle that goes from B to O to C. So that's this wedge right here. Okay, that's this wedge right here. And it is going to be the difference between 130 and 64. Okay, 130 and 64 will leave me 66. Can't make my sixes look the same. It's kind of bothering me. That's better. 66 degrees. 66 is also less than 90, which makes this acute. And then lastly, we wanted to find AOC, which is what you get when you go from A to O all the way over to C, which is the whole larger angle. Okay, it's the whole larger angle. So we can follow the same process. We can do 130 minus 34. Same thing, that gives us 96 degrees. And that's over 90, so that would be obtuse. And then what I'll point it out to everyone in class is that when you take 30 and you add 66, you get 96. Let me clean that up a little bit. 30 plus 66 equals 96. So all that proved was what's called the angle addition postulate. If you have two smaller angles that are side by side, they combine to make one bigger angle, just like the segment addition postulate from last class. Now, this next part we didn't have a ton of time for in class, but I'll still go over it since I'm recording the video. Excuse me. For both of these, we needed to do the same thing. So I'll actually do the second one down here. It says, what's the vertex of the angle? Remember, the vertex is the common endpoint for both of the rays. So the vertex here would be R. The sides are both rays, so I need to use this sign above both of them. And then the first one's going to be R to S. Sorry, don't know why that did that. R to S, it's just not letting me put a line on there for some reason. And the next one would be R to Q, RQ. And then it says name the angle two different ways. So the first thing we have no number, all right, no number there. So we would need to use our three-letter method, which could be SRQ. And then we could also use our vertex method, which would be R. And then it says estimate the measure. Well, earlier we said that a straight line gives us a 180 degree angle, 180 degrees. And we also know that a perpendicular line gives us a 90 degree angle, 90s. So if this straight line is 180 and this angle is somewhere over 90, if I look, it's really close. It's really close to halfway. It's really close to halfway. So that would be 90 plus another 45. All right, 90 plus 45. And so that would give me about a 135 degree angle. Excuse me. For example 5, it says, given that measure of angle 1 is 5x, measure of angle 2 is 7x plus 4, and ABD, which is A to B to D, that's the whole thing. The whole thing equals 100 degrees. Solve for x, and then find the measures of 1 and 2. So if you remember from last class, we said a part plus a part equals the whole thing. So if we take our first part, 5x, and add our second part, 7x plus 4, they should combine to equal 100, because that's the whole thing. And so I can take my x's, and they're being added, so I can put them together. I still have my plus 4 here, and all that together should equal 100. I'm going to subtract 4 from both sides, and that gives me 12x equals 96. And now the last step is going to be divide both sides by 12. So when I divide both sides by 12, x equals 8. Okay, so that's the first part. Now I need to find these two angles. The first one is 5x, which means 5 times x. So angle 1, if it equals 5 times 8, okay, 5 times 8 should be 40 degrees. And angle 2, which is 7x plus 4, angle 2 then, 7 times 8 is 56, plus 4 is 60. 60 plus 40 equals 100. So that all checks out, and I feel like that is a good answer. The last thing I want to point out on 6 is that anytime in geometry when you see things that have common markings, so right now these two angles have this common marking, when you see things that have common markings, they are congruent. So we can say that AOB is equal to COD. Those two angles are congruent. So now the problem starts by telling us that AOB is 3x minus 7, BOC is 4x minus 15, COD is 2x plus 5. It says solve for x and find the measure of all three angles. So we can solve for x because we know that these two equal each other. And so we can just set up a quick little equation here. We know they equal each other, and then we can solve for x. So it looks like 1x equals 12. So x equals 12 is the value of x. Now we can take that x and plug it into every single one of these. So we'll go angle A, angle B, angle C. Angle A is 3x minus 7, so that's going to be 3 times 12 minus 7, which is going to be 36 minus 7. So angle A is going to be 29 degrees. Angle B is 4x minus 15, which is going to be 4 times 12 minus 15, which is going to be 48 minus 15, which means angle B is 33 degrees. And then lastly, we've got C. C is 2x plus 5, which is going to be 2 times 12 plus 5, which is going to be 24 plus 5, which means C is also 29 degrees. And I'm glad that I worked that out because A and C should have been equal, and you can see that they are. And together, the entire thing adds up to 29 plus 29 plus 33, which is going to give me 58 plus 33, 91. I don't know why I still wrote 90. 91 degrees. All right, I hope this helped.